Hi, this is Mr. Ward, and this is a Geometry Do Now 32.3 video key. So I am the key. And in the beginning of this, I am giving you the hexagon area formula. And you need to figure out the area of the shaded parts of this regular hexagon. So the nice thing about the shaded areas is they are half of this hexagon. So you just need to figure out the area of the hexagon using the side length, which in this formula is S. So we're going to use the formula 3 root 3 over 2 times side squared. We're going to get half of that, which is going to change that 2 into a 4. So it's going to be 3 root 3 over 4 times side squared. So let's do that. It's going to be 3, pardon me, square root of 2, times 4 squared divided by 2, and then, of course, we're going to multiply that times 1/2. So that'll simplify into 3 square root of 3 times 16 over 4, because times 1/2 will make that denominator 4. And then that'll simplify even further, 3 square root of 3 times 4. And then we can move the 4 up in front with the 3. So it becomes 3 times 4 square root of 3, which is simply 12 square root of 3 square units. Of course, it's units. Okay, so let's go back and make sure there wasn't a unit other than that. So yes, it's just units. Now we need to find the shaded area in this diagram. Okay, you've got the area formula for the hexagon. You need the area formula for a circle. The area formula for a circle is pi times radius squared. So we need to figure out the radius. So I'm going to set up a structure. It's going to be circle area minus hexagon area. Okay, circle area is going to be pi times radius squared, and the hexagon area will be 3 square root of 3 over 3 times side squared. Let me confirm that I remembered that formula correctly. I'm going back and referring. Oh, no, so I've got to correct this. It's over 2. Okay, I'm glad I checked that. So let's see what we know. So we know pi is roughly 3.14, but we're going to leave it as just pi. The radius of this, well, this is a bunch of equilateral triangles, and since it's a bunch of equilateral triangles, we can do this. Remember, it's 6 equilateral triangles that all intersect in the center, which means the radius, so if this is roughly the center, if I drew it a little better, they'd all intersect in the same place. The radius is going to be the same as the side length. So the radius is 16. So it's pi times 16 squared, and that's going to be minus 3 square root of 3 over 2 times 16 squared. So 16 squared is showing up in both of those. So I could actually pull the 16 squared out, and I'm just going to deal with that. That's going to be 256, 16 squared. I'll say 16 squared here, and then I'm going to have in parentheses pi minus 3 square root of 3 over 2. Okay, I've just distributed that 16 squared out. So that's going to be 256 times pi minus 3 square root of 3 over 2. And that'll be units squared. Now, if you needed to get, and that's actually a good enough answer for right now. Okay, if you wanted to get something a little more precise, we could just take this and we can put it into a Desmos. Let's do that. I'm not really more precise, an estimated thing. This is actually what you have there is an exact answer. Okay, could be tidied up, possibly even more. Okay, so let me make Desmos happy, pi. Okay, and square root 3. That's over 2. Okay, so let me actually organize some of this stuff. So we've got 256 times pi. If we wanted to, we could also write it as 256 pi minus, and then we'll say 256 times 3. That'll be minus 768. That's over 2. Let's make that 768 over 2. So that's 384. 384 square root of 3. And that's a little more organized, more elegant answer than what we had there. So I'm going to put that in here so that will actually be here. Okay, so that's going to end up being, once again, 256 pi. Let's see if I can copy that in. Okay. Sort of. Okay, so 256 pi minus 356 square root of 3 units squared. Okay? And of course, when we were in Desmos, it did give us an estimated answer, 139.14. So we'll put that in there. That's exact. And 139.14. 139.14 square units estimated. Okay, because that is an estimated answer. I had to round it. If I kept going out here, that's a rounded number. I couldn't just copy all of that. But that is your answer. Okay, let's go to the next one. Now we need to get we're trying to use special right triangle side relationships to calculate the span of this regular octagon. Okay, so we have this square. The side of the square is 6, which means that this part is 6. Okay, so span is going to equal side of hexagon plus 2 times the 45, 45, 90 triangle legs. Okay, or a leg. Okay, so we can work that out. So span will equal 6, because the side of the hexagon is the same as the side length of the square in the middle. Okay, 6 plus 2 times, all right, so these things are the two things we're getting. So if this is 6, because that's all of these sides are 6, then this is going to be 6 over root 2 times 6 over square root of 2. And we can simplify that further. So it'll be 6 plus 2 times 6 square root of 2 over 2. And the 2's are going to cancel out. So it's going to be 6 plus 6 square root of 2 units, whatever those units are. And I think that's it. This is a good place to stop.